So our session today will be on capital budgeting. So when I'm dealing with capital budgeting, we are going to look at how we plan as an organization. So under capital budgeting, we're going to look at techniques that a business uses to analyze investment projects and assessing the best alternative that they can take using their skills or techniques. So capital budgeting basically describes the decisions where expenditures and receipts for a particular undertaking will continue for a period of time. So in capital budgeting, we're going to use aspects of time value of money. So usually we'll be looking at cash outflows and cash inflows in the early periods, or the cash inflows will be considered for later, and seeing the periods of time within which certain cash inflows will be recovered. So when firms decide to invest in projects, usually they will have to analyze the investment to see how best the project that they want to undertake will be viable. So the process is actually called capital budgeting. So there are several types of capital budgeting techniques that we're going to look at. So techniques in capital budgeting include expansion of already existing facilities, coming up with new products, replacing the old products for new, leasing or buying, making or buying, and also considering the safety and environmental protection equipment. So time value, like I said, will be vital in capital budgeting because you're going to see the viability of $1 today compared to that tomorrow. So whenever we're dealing with cash flows, we're going to discount them now to seeing whether it's viable to invest, considering the future cash flows that we're going to receive, or making an outright buy. So the investment alternatives or appraisal techniques that we're going to look at, number one, will be payback period, which is one of the easiest. We'll also look at what is called net present value, which is NPV. We'll also consider what is called profitability index. We'll also look at what is called IRR. And finally, we'll look at a technique called the ARR, which is the accounting rate of return. Now, when we're dealing with payback period, we're basically looking at a method which measures the length of time that the project takes to pay back its initial investment. So the shorter the period, the more viable it is when you're dealing with the payback period. So payback period could be in years plus decimals or years plus months. So if you have 2.5 years, basically you're looking at 2 years and 6 months. So we're going to consider two types of payback period. There's what is called the discounted and the non-discounted method. And whenever we're accepting a project using payback period, usually projects that have a shorter time period are acceptable over those ones that are longer. If you're comparing two projects, one will give you back your initial injection within 2 years, the other one takes 5 years. Obviously, you pick an investment whose payback period is shorter, in this case, 2 years. So we're going to look at an example using the payback period. For instance, Unilas is considering investing in a new project, A and B. Now, the university has determined the after-tax cash flows. For project A, we're expecting 400, 400, 400 for the years respectively. And their initial investment was 1,000. Then we have project B, which is giving us 600, 400, 200. Also, the initial investment or the initial cash outflow is 1,000. So which of the two would we consider? Now, When we're considering payback period, we have a formula that we're going to use. So the outflows that we have here, starting from year 0, are given as follows. So we have 400, 400, 400. So for year 1, for project A, so year 0 mainly looks at our initial cash outflow. So the cash outflows that we have the 1,000 is how much we started with. We usually put it in brackets. And then we have 400, 400, and 400. Then you have the cumulative frequency. So here we have 400. When we add to the 400, we're going to have 800. When we add to the 400, we're going to have 1,200. So when we are calculating the payback period, A plus C over D. So we're going to look at the period within which the 1,000 kwacha was paid. So at 800, we haven't yet paid the 1,000. At 1,200, we have even exceeded. So we'll look at the year which first in between which the amount is going to be paid. So the 1,000 is between what? 800 and 1,200. So this is what our A. So where there's A, we put what? 2 years or 2. Then if you want, we can call this B. Then C and D. So the difference between C minus D is the amount that we are remaining with to meet our initial cash outflow. So 1,000 minus 800 is a 200. So here we're going to put 200 over the actual cash outflow in the next cash flow period. So we have a 400 here. So this is 400. So we're going to have 2, then this is 0.5. So you can align this time as 2.5 years, or 0.5 can be multiplied by how many months? The 12 months. So 0.5 is the same as half. Half of 12 is 6. So this is 2 years, 6 months. I repeat, it's easier to consider it like this. If you have years, for instance, we have 1,000. So this is my initial year. 1, 2, 3, 4. So the cash outflow, the cash flow, maybe we set it with 1,000 kwacha. In year 1, I'm just going to change the denominations. 200. Year 2, 300. Year 4, we have 400. Year 5, we have 500. So we're going to have the cumulative cash flows. So we can do this. 200, just bring it here. 200 plus 300, we have what? 500. 500 plus 400, what we have? 900. 900 plus 500, what we have? 1,400. So we look for the period within which the amount is paid. So it's between 900 and 1,400. So we pick this here as our A. So payback period will be what? A plus C minus B over D. So we can call this our A, We can call this our B, then we have C and D. So our A is 3 years, then the difference 900 minus 1000 is 100. Then D is the actual cash flow here in the next period, that is 500. 500. So here we're going to have 3 plus 0.2. So this is the same as 3.2 years. People make a mistake to say 3 years, 2 months. This is not 2 months. To get it in terms of months, we multiply 0.2 and how many months we have? 12 months. So this one becomes what? This one becomes 2.4 months. So it will be 3 years and what? 2.4 months. All right. So the other example that we had, we are told in this project, we have 600, 400, 200. So already, if we have a cash flow, the 600 comes here, the 400 comes there. 600 plus 400 is 1000. So exactly in 2 years, our payback period is done. All right. So on payback period, I don't want people to get confused. It's the easiest of them. It's the easiest of them when we're dealing with a payback period. So I'll be moving gradually so that we look at 2 examples from our tests and our exams. So I want you to help me calculate the payback period for this one, the undiscounted payback period. So this question, in a nutshell, the initial investment was 300,000. Let us calculate the payback period. Who wants to try? Anyone to try? For year of 0, 1, 2, 3, 4, 5. So what do we put on year 0? The cash flow. 300. Then 20. Then 50. Then 150. Then 160. And finally 170. Then what we do? We get the cumulative cash flows. So this is 20. Then we have what? 70. Then we have what? 150 plus 70. We get 220.
20.
Then plus 160, we get what? 380.
380.
Then plus 170, we get 550.
550.
Then what is our A? We identify where the 300 will be extinguished. So which period are we looking at?
3.
This period, eh?
Yes.
So our A is here. Our B, our C, and our D. So 3 plus what? The difference between 220 and 300, which is what? 8. Over the actual cash outflow, which is 160. So 8 divided by 160, 0.5. So the payback period is what? 3.5 years. Are we together?
Sorry, friends, my network I think was interrupted. I don't know if you can just run over, just I think on the main points.
Yeah, and also how you're identifying the letters.
Unless you joined late, because I think this is what I've been trying to explain. To say, let's look at another example first of all, maybe I explain from it. But okay, so immediate test question. Number 1. Let's look at the who wrote this test. Can you help me identify payback period? Just the original question. Okay, so payback period basically looks at the period within which we pay back our initial investment. So we have two machines, machines 1 and machines 2. Some noise in the background. So if you're given two machines or two projects A and B, and you're being asked to calculate the period of time within which you're going to pay back the initial cash outflow. Year 0 is always our initial immediate cash outflow. Year 1, year 2, year 3, year 4, depending on how the question has come. So capital budgeting basically looks at the time period within which our amounts are recovered. So here we have maybe 100, we have 300, we have 700, and we have 200. Maybe here we have 500, we have 800, we have 200, we have 100. So we want to use what we call the payback period to calculate how long it will take for us to recover our initial investment of 1,000 for project A and project B. So let's start with project A. So for project A, we're going to compute our what? Cash flows. So we have here 0, 1, 2, 3, 4. Then we have the cash flows. So cash flows here, the initial one we started with is 1,000. Negative there. So here we have 100. And next we have what? 300. And here we have 700. And we have 200. Then we accumulate them. So we get the cumulative frequency. Starting from here, 100. We add to 300, we get what? 400. We add to 700 to get 1,100. And we add to 200, we get 1,300. Are we together so far?
Yes.
Then we identify
Yes,
that where is the 1,000 first paid, within which range between these two values. That's where the 1,000 will lie. So you pick the year for the upper value here. This is our A, and this will be our B. Then this will be our C. This is the first value. Then our D will be here. So to find the payback period, we're going to say A plus B minus C over D. So our A is what? 2 years, so 2. And the B is 1,000 minus what? 400. over the actual cash outflow, 700. So this would be 2 plus 600 over 700. So we're going to have 6 over 7 plus 2. So our payback period will be 2.857 years. All right. So with that being said, I want you to try, give me the payback period for project B. I'll give you 5 minutes.
Sorry, Collins. I just wanted to understand on how you were able to select that A has to be here and C has to be here and D has to be here. Is it relating to how the question was being asked?
Well, can somebody try to answer that? How do we identify A, B, and C?
Collins, maybe I could help.
Mhm.
From what I've noticed, the A, you pick the period, the year in which
Is that my network or her network?
Me too, I've lost her. I didn't
Maybe it
get
has.
So when you go here on the cumulative values, you identify first where the 1000 lies. The value which is equal to 1000 or first exceeds 1000. So 1000 is between, if there was exactly 1000, you would pick the 1000 itself, we would just end there. So this is 2 years. But 1000 is between 400 and 1100. So the first figure here on the cumulative value, straight, you pick the year there, that is your A. Your B is your actual injection, the amount you put. The C is the first value before the amount 1000 is made in the cumulative value. Okay, and the D is the next cash outflow after which the year we picked falls. So 2 years, we pick this cash outflow in short. How much do we need to add to this 400 to get 1000? It is 600. So what we mean is simply the difference between 600 and 1000. Then we add the cash outflow, which flows in the next year, 700. So here, if there was 800, how much do we need to get to 1000? It is 200. So we'll put 200 there. Then the next cash outflow, which is 700. I think you just need to master the pattern. We don't need to take so much time on this period. We have 4 other more. Or use the same.
No, I've understood. I think I just need to go through it on my own also, just to memorize or understand how you put in the formula and everything.
All right. So project B, quickly, within 2 minutes, I want you to try here on your papers. Give me the payback period. Okay, let's look at project B. So project B, we are looking at the cash outflows. So the years that we have, 0, 1, 2, 3, and 4. The cash flows that we have, what cash flows do we have? Started with how much? 1000. And year 1 has what? 500, 800, 200. 5, 8, 2, 1. 5, 8, 2, and 1. Then we accumulate them. So we have 500 here, then 1, 3, then 1, 5, then 1, 6. So the 1000 will lie between these two, right? Isn't it?
Yes.
What is our A?
A is 1. A is 1.
B,
B is
1000,
C,
C 500,
D.
D 800.
Payback period is what?
So just there I got confused. Because, hello, sir.
Yes, I can hear you.
Yes, the formula is 2 equals 500 over 800, not so.
No, 1 plus
Oh, it's plus. Okay.
1
Oh, I
plus
was putting a sign.
1000 minus 500 over what? 800.
800.
1 plus 500 over 800. Did anyone get this?
Yes, I did, but with me, I was putting equals.
So who got this answer?
The answer I
I
didn't
did.
get.
$1.625, that is the payback period. Okay. Are we together?
So I have a question.
Uh-huh.
Yes. Why are we using 500 as C? I was thinking we're supposed to use 1,300 since it's above 1,000.
It's the difference between B and C. I said first look for the actual year, then go into this line, look for the cumulative figure, the difference. How much do we have remaining to get to our initial outflow? The difference between this one and this one, that's the 500. Then the D is the next cash outflow, not in the same line, but in the next. Different books have different formulas, but ultimately you get the same answer and you get the concept.
Okay.
This
Okay,
amount.
thank you.
Yeah. All right. Another appraisal method is called the net present value. So we have what we call the discounted. It's actually discounted. Net present value is used to compare the present values of the cash outflows for a given project based on the initial cost. So the future cash outflows will actually be discounted to come up with the net present value. This kind of appraisal method is based on the acceptance or the rejection rule, which simply assesses that whenever our NPV is more than 0, we can say the project is not viable. But if you have two mutually exclusive events, you pick one which has a higher NPV if both of them are positive. So this has an advantage in that it takes account of time value of money. It also uses cash flows, not profits. It also takes account of relevant cash flows over a period of time. It also can take account of the conventional and non-conventional cash flows. As well, it gives absolute measure of the project. The disadvantage is that this project may be difficult to estimate. Also, accepting all projects with positive NPV is only possible in a perfect capital market. The cost of capital, which this one uses, is difficult to find or estimate. And also the cost of capital may change with the period life. So we cannot use one in real life, one appropriate discount rate. So using the same examples, I'll do project A, you do project B on NPV. So we have these projects here, 1,000, 100, 300, 700, and 200. So 1, 3, 7, 2. So project. So we have year 0, 1, 2, 3, 4. The cash flows 1,000 here. And here we have 100, 300, 700, 200. Okay, then we have the discount factor. We're talking about, you can be given any discount factor. Let's use 8%. That is the cost of capital. Suppose the question gave us 8%. All right, so we want to have the present value. So our discount factor will simply be 1 plus R to the power negative N. That is what we'll be using. So here we're going to multiply this one by 1. Our R is 8%. So 1 plus 0.08. Or negative 0. This one is simply giving us what? 1. So our present value here will be 1 times negative 1,000. We'll get negative 1,000. And the next one here, we're going to have 1.08 to the power negative 1. This one will be 1.08 to the power negative 2. This one will be 1.08 to the power negative 3. This will be 1.08 to the power negative 4. These are discount factors. If you're given 6%, it will be 1.06, 10%, 1.10, 15%, 1.50. You will always be given a percentage. So these discount factors simply give you they simply give you the value when we're going to discount 926. The value of this 100 kwacha today. Okay. And 100 kwacha. This is actually 92.59. 1.08 to the power negative 2. The discount factor here is 0.857. So multiply this by 300. This will be, this 300 is actually today with 257.20. In short, it's as good as saying, would you rather wait for 300 kwacha after 2 years or get it now? If you're getting now, they can't give you 300. Because of inflation, it will be discounted. So this 300 is worth 257 today. And this 700, how much is it worth today? Instead of getting it after 3 years, so we calculate the discount factor. So discount factor, or who can help me? 1.08 power negative 3 is 0.794 times 700. It will be 555.68. All right, then finally 1.08 to the power negative 4. The discount factor here is 0.735. You multiply this 200 there. So it will be 147.00. All right. So the sum total is what we call the net present value. So these figures here, you can add them if you want. These are called the sum total of the present values. So 92.59 plus 257.20 plus 555.68 plus 147.01. So what we're going to get, this total here is what? 1052.48. So since this is negative, we're going to subtract 1 minus. I'm going to subtract this minus, so 1000. So this is called the net present value. So net present value is what? 52.48. So this is what we call our net present value. Remember from our notes, we're saying the project is viable on 2 grounds. Number 1, if it's a positive, or meaning more than what? 0. Number 2, if it's greater than the other one. So this is the net present value for project A. Then the profitability index for project A is simply found by the summation of the present values over the initial cash outflow, the initial cost. So we always select a project if the profitability index is more than 1, or when the NPV is positive. So here, if we divide this one by 1,000, ICO means the initial cost in short, 1.052. So this is the profitability index. So profitability index is easy to calculate, especially after you calculate your NPV. These ones move together very easily. Okay. So I now need you to do the same for project B.
Sorry, Collins, just a question.
Uh-huh.
I understand how you got these other figures from DCF, but for the PV, I've been trying to find which one were you adding with the
Multiplying just this
DCF
time. This one times this to get that.
Oh,
This times
all
that
right.
to get that.
Okay. All right. Noted. Thank you.
Okay, any other questions?
Okay, so when you get the net present value, when you get it wrong, it means even the profitability index will be wrong, isn't it?
Exactly, yes.
Sir, just a confirmation. Is this FMA or it's another course? Because I'm so lost.
It is, yes. This course is found both in corporate finance and FP. It's actually question 1 of your exams.
Okay.
Yeah.
I didn't see the question paper, so I don't know if you can post it in the group so that I can download it.
All right.
Sorry, Collins, can I help a bit?
Uh-huh.
I think maybe she's kind of because I think this one we haven't been taught yet, so maybe that's why she might not know about it, because it's almost the last, I think the last lesson thereabout, or last but one.
Yeah, I taught it because it's independent of everything I've taught you before. So anyone who's joined this should be able to not use any previous information I've taught you, unless you joined late. I took my time to break this down. Okay, so I'll need you to now calculate for project B. Give me the profitability index and the NPV. You summarize them as follows. So project A and project B, NPV, profitability index, and the payback period that we already calculated. Then let's give me a conclusion which one is better than the other, so you can start.